Welcome to This Explainer. Today, we're diving into a massive topic in the industrial world, predictive maintenance. If you'd been anywhere near manufacturing, food processing, or utilities lately, you've definitely heard the pitch. It's constantly sold as the natural, inevitable next step after preventative maintenance. And honestly, in many plants, it absolutely is. But here's the catch. It requires a whole lot more than just buying some shiny new tech. It needs clean data, serious sensor investment, and a maintenance team that's ready to interpret signals instead of just following a calendar. So today, we're going to cut right through the vendor sales pitches and the hype. We are looking strictly at the grounded, operational reality of running predictive maintenance programs on real equipment with real budgets.
Here's our roadmap for today. First, we'll look at the actual promise of predictive maintenance. Second, what fundamentally changes on the shop floor. Third, 4 crucial factors for success. Fourth, we'll bust some common myths and obstacles. And finally, making the call on implementation. Let's get into it.
Section 1, the predictive maintenance promise, and looking way beyond the hype. There are some absolutely massive industry stats floating around out there, but before we get into the gritty reality of implementation, we need to define exactly what the end goal looks like. Why is everyone chasing this? Well, predictive maintenance, or PDM, uses sensor data, things like vibration analysis, thermography, and oil analysis, to act as condition indicators. The whole goal is to schedule maintenance based on the actual real-time health of the asset, rather than relying on a fixed calendar or run hours. We're moving away from time-based assumptions and shifting entirely to health-based realities. And the sheer scale of the potential impact here is staggering. The economic case is heavily documented. Industry analyses based on McKinsey research show that shifting from reactive or purely preventive strategies to predictive maintenance can reduce unplanned downtime by 30 to 50% and cut maintenance costs by 18 to 25%. But it gets even better. The U.S. Department of Energy has actually documented that mature predictive programs see breakdown reductions of 70 to 75%. That is a massive operational shift. The financial reality behind those breakdown reductions is actually pretty simple. When you catch degradation early using predictive data, that proactive repair is typically 4 to 5 times cheaper than an emergency repair on the exact same asset. Why? Because you aren't paying crazy overtime rates for an emergency weekend fix, you aren't paying for expedited parts shipping, and most importantly, you avoid the secondary damage that happens when one single failure cascades into the surrounding equipment. All right, Section 2. What changes on the floor? The operational reality. So that all sounds fantastic on paper, right? But stepping away from the optimistic industry stats, let's think about the grounded reality using this analogy comparing the preventative mindset against the predictive mindset. In a preventative system, you replace a bearing every 2,000 hours, simply because that's the schedule. It doesn't matter if the bearing is perfectly fine or if it's about to shatter, but in a predictive system, you replace it when the vibration signatures actually show it's degrading. That might happen early at 1,400 hours, saving you from a catastrophic mid-shift failure, or it might not happen until 3,200 hours, which literally saves you the cost and labor of replacing a perfectly healthy part. Because of this shift, the daily routines of your staff fundamentally transform. Your planners stop scheduling around worst-case assumptions and start scheduling around actual condition data. Your spare parts inventory strategy shifts from, we need to hoard this just in case, to, we need to have this part ready because the sensor says we'll need it in exactly 3 weeks. And your technicians? They spend far less time doing routine inspections that find absolutely nothing wrong. And if you've ever walked a preventative maintenance route on healthy equipment, you know that is the vast majority of them. But remember, none of this happens automatically just because you bolted a sensor to a machine.
Moving on to Section 3, 4 factors for success. Consider this your litmus test.
Look, predictive maintenance is a tool, not a magic upgrade. It pays off on the right assets, and it's a huge drag on the wrong ones. So Factor 1 asks a very blunt question. Is your asset downtime actually expensive? This is where you have to look past the cool technology and look directly at your ledger. If an hour of downtime on a specific machine only costs you a few $100, investing in sensors and analytics for it rarely pays back fast enough to matter. But if that downtime costs tens of thousands of dollars because it's a bottleneck line or a safety-critical system, predictive maintenance will often pay for itself by preventing just one single failure. You have to rank your assets by downtime cost, not just by their age or a basic criticality score, to justify the investment. Let's move to Factor 2. You really need to probe the nature of your equipment failures. Ask yourself, do your assets fail randomly? Here's the hard truth. Not every failure mode is predictable. Predictive maintenance works beautifully on assets that experience gradual, detectable degradation, things like bearing wear, misalignment, or lubricant breakdown. It works incredibly poorly on assets that fail randomly or catastrophically without any measurable warning signs. Forcing expensive sensors onto equipment that fails randomly is just a really fast way to burn through your maintenance budget.
Factor 3 challenges your current data hygiene. Is your data clean and structured right now? Because this is a massive failure point for pilot programs.
Sensors generate raw data, sure, but useful predictions require a clean historical baseline of failure events, work orders, and maintenance actions so you can train your models or benchmark your thresholds. If your plant is currently running on paper records or scattered spreadsheets, you usually need 6 to 12 months of disciplined data capture inside a structured CMMS before predictive analytics will produce anything actionable. Skipping this foundational step is the single most common reason predictive maintenance pilots underdeliver. And factor 4 is team readiness. Take a look at the demographic cliff and skill gap facing the entire industry right now. According to Deloitte and the Manufacturing Institute, roughly 69% of maintenance professionals are over the age of 50, and nearly 1.9 million manufacturing jobs are projected to go unfilled by 2033. Reading a vibration trend and knowing when to trigger a work order requires specific training that your current team might not have. There's a quote from the source material that hits the nail on the head here. A predictive maintenance system that generates alerts nobody on your team is trained to interpret is an expensive dashboard, not a maintenance strategy. If your people can't read the signals, the sensors are completely useless. Okay, section 4, common questions and obstacles. Time for some myth busting. Let's address the most frequent roadblocks directly. There are a lot of myths out there about what it actually takes to get one of these programs off the ground. First, people always ask, how long does it actually take to see ROI? Well, here is a realistic timeline. Payback typically ranges from 8 to 18 months. However, facilities with incredibly high downtime costs can sometimes break even in just 3 to 6 months, simply because avoiding one major failure covers the whole program cost. But you cannot shortcut those first 6 to 12 months needed to establish that CMMS historical baseline.
Let's rapid fire some other common myths. Does predictive maintenance replace preventative maintenance entirely? No way. They work alongside each other. Routine lubrication, filter changes, and safety checks stay on a calendar. Do you need a whole team of data scientists? Nope. A modern CMMS and condition monitoring platforms handle threshold-based alerting just fine. Custom machine learning is really only for complex, high-value edge cases. And finally, do you need a massive IoT sensor network? Partially, but you can actually deliver great early predictive insights using manual condition monitoring routes with handheld vibration meters or oil sampling. Which brings us to our final section, Section 5, making the call and building the playbook. So here is how we build a pragmatic, no-nonsense rollout plan. The right move for most plants is never an all-or-nothing, boil-the-ocean rollout. Step 1 is always securing a solid data foundation. Your data has to feed into work order generation, and your planners must trust it. This is exactly where a structured CMMS earns its keep well before the first sensor ever gets installed. You want platforms globally proven to sit right between lightweight SaaS tools and heavy enterprise suites, like ManWinVin, for example, to offer the structured management you need. Step 2. Identify just 3 to 5 critical high downtime assets where failure patterns are actually measurable. And Step 3. Prove the model on those specific assets and only expand once the numbers hold up under real operating conditions. Predictive maintenance absolutely earns its keep, but only when downtime is expensive, degradation is measurable, and your team is ready. If downtime cost is low or your records are a mess, it's going to be an uphill battle. So I'll leave you with this final thought to chew on for your own operation. Is your plant actually ready for predictive maintenance today, or do you need to fix your data foundation first? Thanks for joining me on this explainer, and I'll catch you on the next one.